So I'm Gareth Lloyd. I actually run these ACCU York meetups. I'm also a senior software developer at a database company called MemGraph. And this is my little talk called Is That C++? So at the beginning of the year, I wrote this bit of code. And all it does is print out all the dates and times for all the ACCU York meetups happening this year. And so to answer the question at the beginning of the slide, is this C++? The answer is yes. And some of you in this room have never done C++, and you're like, so what? Others of you in the room have seen C++ before, and you're going, wait, that can't be C++, that's way too short. What the hell is that feature? I've never seen that before. But this is, code that I'd expect somebody who's up to date in the C++ language to be able to write, and it's actually quite concise, ergonomic, in my opinion. So I'm going to actually use this as an example to talk through some aspects of C++. So if you're not familiar with C++, it will actually probably tell you one or two things about it that you didn't know. So let's start off. First of all, C++ is a strongly typed language. All right, I get that it has a history with C, and C has a lot of implicit conversion as it's a weakly enforced language. But C++ is a strongly typed language, and we kind of avoid all those implicit conversions as much as possible in order to make, robust libraries that you can use. So this is true in many programming languages. You do not want the integer 2025 to represent years. You actually want a strong domain type. So this will actually be std chrono year. But that's a really big mouthful thing to construct and type. So actually, there's a really good ergonomic feature within C++ of user-defined literals. And you can do it for arbitrary types. But this one is for std chrono year, and it has a suffix y. So you get this nice ergonomic way of constructing with no real overhead. It's just nice syntactic sugar for constructing a std chrono year. I've kind of jumped over a bit of C++ history because it's not like C++ came out, with every single feature that you wanted straight away perfectly. So in C++ 11, yes, we did get Chrono. But when it came out in C++ 11, what you got given were clocks and time-related things. So you could ask a clock for a time point, and you could actually play around with hours, minutes, seconds, milliseconds, nanoseconds, etc. And they're all about duration. And you've got all the methods around these types such that it's stopping you from doing the incorrect thing. So I can take a duration and add a duration and get back a duration, perfectly fine. I can have a time point and a duration and get back a time point, also fine. If I try to take a time point and add a time point, that's a compilation failure. So using strong types, and this is not just true for C++, it's true for many languages, using strong types to prevent you from doing the wrong thing. And it wasn't until C++ 14 that we actually started getting the user-defined literals in. So we've got the time literals. So now you can actually, in a very ergonomic way, spell out 18h plus 30 min, and that tells you 6:30 p.m., right? And then eventually, after many years, we get to C++ 20, and we actually get dates, so all the calendar stuff. So we can start talking about years, months, and days. And in fact, if you take a look at line 15, line 17, we can talk about the first Wednesday of a month, which is very different from on line 25, where we turn it to local days, and that actually turns it into, for example, today, September the 3rd, an actual date. And we can still add that onto a duration to get a time, and that time isn't based anywhere in the world. So in order to actually say that this meetup exists somewhere here in York, let's tie it to the Europe-London time zone, and so we actually have zone time. So you've got all these strong types making sure that you can do everything correctly. I've kind of already hinted at this, but I'll explain it in a bit more detail. So C++ has overloading. What this means is that you can have multiple functions with the exact same name and their different implementations, and the way that you statically differentiate between them is the arguments that you pass in to that function. So if you had a function that took in an integer, called, foo, and then you had another function which took in a double called foo, you could have two separate implementations for that, and the overloading would pick the right one statically based on the types that you passed in. Operators are nothing special. They're just another function, but they allow you to have little syntactic changes. So you can actually have prefix, postfix, or infix operators. So operator slash is one of those infix operators, and this allows us to have the ergonomics to be able to compose dates and stuff with a nice concise format. So we can say 2025y/February, and that's a very nice way to construct a year_month. the variable that we've assigned this to, we could actually spell it out in a very long form. We could say stud chrono year underscore month, but that's noise again. So in order to keep things nice, small, and concise, we can actually use placeholder type specifiers, which also came out in C++11. This isn't like some magic variable that can take anything. It is deterministically done by the compiler that what's on the right-hand side of the expression, it is a stud chrono year month, and that variable will only ever be a stud chrono year month. So I'm going to get a bit of a sidestep away from this code to show you a few more things that have happened over the years in order to make the ergonomics of C++ better. So pre-C++11, the standard template library is brilliant, it's wonderful. We have generic containers and we have generic algorithms. But in order for them to work together, there's a concept in C++ of iterators, and that is like an abstract way that they can communicate to each other to say, this is how the container is navigatable and how do you read elements out of that container. But pre-C++11, you'd have to spell out that iterator type in its full form. So you go stud, vector, int, const iterator. That's a mouthful. So already you can see just by using auto, it makes this simpler. We know that cbegin is going to give an iterator. We know this is a C++ language, and we know about iterators. We know that's going to be an iterator. This is also a very common iteration pattern. You're going through a container and looking at everything in that container. So why not have some syntactic sugar for it because it's so common? And that's what we've got. So we have this range-based for loop. And now we no longer need to actually specify anything about the integers. It's all hidden away, syntactic sugar behind this. So we still have the container that somehow behind the scenes is getting those iterators. We're going to iterate through those and dereference it to get our value out of it. Whilst we're talking about cleaning up code, if you take a look at line 5 and 6, we are constructing a vector, and then we're actually going to push back a value onto it. And that seems a bit, bit too much. 2 lines I know is too much, right? So what we can do in C++11 is actually tell it, these are the values that I want you to construct at construct time, okay? So I can say with an initializer list, which all of that initializer list contains is the value 42. At construction time, please populate that 42. So it does it all in one go. You'll also notice, in the previous slide, I had to spell out explicitly that this was so vector is a generic container. It is a generic type on there to say that all the elements inside of it are going to be integer, and I had to explicitly say that here. On the next slide, I'm using C++17's class template argument deduction in order so I don't need to do that. And there's a bit of machinery going on. So the initializer list is also templated, and it's saying it's an initializer list of integers, and automatically at construction is tying this together to say, oh, I know what you mean here is that it's going to be a stud vector of integer. Again, making things concise. For completeness, me being a performance freak, in this little demo thing, I have to say I'm going to use array instead. So a vector is a dynamically allocated array. It's on the heap. If I was going to do this in some production code, it'll be a stud array, which will do it here on a stack instead. OK. So I've already talked about a bunch of things that you can see in other languages. Strong types, a bunch of features that make things a bit more ergonomic, so that you can actually have smaller code and less boilerplate. But what is it that draws me to C++? And it's this idea that I can actually move stuff from runtime that doesn't have to be done at runtime. It's metaprogramming. I can do that at compile time instead. So what this constexpr is doing is saying, this variable that I'm initializing right now, make sure anything on the right-hand side of this expression must have been done at compile time. And what this means is that all the code that comes after this that depends on first month, it can actually inline that value and have better code gen because of it. OK, so let's talk about a bit more evolution of C++. This is what metaprogramming used to look like. This is known as template metaprogramming. And you'll notice compared to many other languages, generic systems, so C++, not only can you pass types in the generic arguments, we can actually pass values. Not many languages can do that. There is restrictions on what values you can pass, but here we're just having int of n. So at the bottom on line 17, when I'm instantiating fib10 and then getting out the value from that, that goes to the top template right at the top, and that recursively instantiates fib9 and fib8, and it keeps on recursing all the way down until we get to the template specializations, fib1 and fib2, which have hard-coded their value to be 1. And this all bubbles all back up to, say, 55 at compile time. Put your hands up if you think this is code that you want to write on a day-to-day basis. Right, there you go. No hands were shown. So this is how we do it today. And so this is a constexpr function. So it looks like normal C++, apart from all we've done at the beginning, we've put constexpr. And what this basically means is this implementation of fib, we can actually run at both runtime and compile time. And to do that, we've actually said, we've got some restrictions on what we can do inside that function. For example, you can't allocate at compile time and deallocate at runtime. That makes no sense. So constexpr is protecting you from a whole bunch of undefined behaviors, etc. So on line 11, when I have this constexpr variable, it's forced that that fib10 must have happened at compile time. So this is the way that we do metaprogramming today. Right, so all this has built together to this big thing here. So what we're going to do is, as I say it's big, it's printing out a string, right? But we're actually going to tie this whole idea of having some ergonomics, some moving stuff from runtime to compile time, and try to do some good code gen. So what's happening here? We've got print, which has also got a format string. So it's not actually a format string straight away. This is one of the few cases where you actually get a little implicit conversion. That is actually C string literal that gets implicitly converted to a format string, but it uses stuff that print is saying in order to make that work. So it's found in that format string that there's two placeholders, right? And both of those placeholders are referring to the 0th argument. So print has said, these are the arguments. There's only one of them. So in the 0th place, there is something. Great. At this point, we do not get a compile time failure. There is at least the 0th argument for us to do our formatting with. The 0th argument, Meetup, happens to be type zone time. So again, the format string is going to go away and say, is there a formatter for zone time? And yes, at compile time, it can find a formatter. All good. It's then going to say, right, I'm now going to parse this at compile time, %b, %d, %r, %z. Do those formatting options make sense? And it goes, yes, wonderful. So it's going to make some high-quality code that can be run at runtime, which will extract only what's needed out of the Meetup variable, because it's a zone time type, and then efficiently fill in your print buffer with whatever's needed to do that at runtime. So this is a very efficient code gen going on from this. OK. So I just talked through that bit of code, and hopefully almost every line should make sense to you now. Yeah, sure, many languages have strong types. Many languages have a lot of ergonomic features. Fewer languages have the ability to move stuff from runtime to compile time, and that's one of the major reasons that I have for using C++. And even if you aren't going to use C++, never stop learning. This stuff can be just a little thing on the side of your brain going, actually, that's a different way of approaching this problem. This is what it actually printed out. And as you can see, we have September the 3rd, 1830, British summertime. That all worked out nicely. And this is my pitch to say, please come along to the meetups in the rest of the year. There's one in October, one in November, and one in December. I do actually have a couple more little bits of C++ code that I can show if there's no questions, because these are things that exist in C++ that you might not find in many other languages. So let's first of all, any questions?
First of all, did I understand right that you showed format strings are checked at compile time?
Yes.
If you write that format string wrong, it won't compile. Because that's really cool. I might become a C++
so
programmer now.
If I put %f in this, I get a compile time failure.
I'm over Kotlin now. Okay. Second question. Do you think that operator overloading can go too far? I mean, some of those operator overloads I look at and I think the slash for the year, month, day, and the indexing operator for the first Wednesday of the month, it's not entirely intuitive because that's not doing what that operator would normally do. It's not doing division or array indexing. Do you think that's a valid criticism of kind of going so far down this route?
But this is true in many languages where you're down in a domain-specific language. Like you are reusing symbols and tokens in order to make something ergonomic within that domain. And I don't think this is a bad ergonomic decision for saying, oh, rather than having to say dot add month, dot add day, like it's an alternative syntax. And it may be obvious to you, or it may not be obvious to you, but I think it depends on what the the code domain you're working with. If you're doing stuff with times and dates all the time, this is going to be like the way you want to code. If you're not, then maybe you want to do the more verbose way because it's not that common in your code base. Therefore, you want to spell it out in the long form with constructors and with dot method, etc., etc.
That's a fine line, isn't it? I mean, it's, sometimes you step over that. It's those were paths when you compare with like, for example.
I mean, I don't know if I'm necessarily complaining. I'm just curious where the line is.
It was paths. You recognise it much more.
Yeah. I mean, have you seen code where you think, oh, they've gone too far, that operator doesn't make sense?
I mean, the first complaint in all of C++, the first complaint with C++ history is the first big usage of this was streams. So right now, we're now using like print. It used to be that you were streaming things in or out, and you'd have like the bit shift operator, the chevrons, and that was like practically the only usage that it was within the standard library. It was weird, and people didn't like it. And there's other libraries which I think go too far. So I think Boost Spirit comes to mind. Yeah, I'm getting a nod. So yeah, Boost Spirit really goes to town, but it's trying to, again, it's a DSL. It's trying to make a particular domain take less code to type. Yeah. Anybody else want to make?
More an observation I find funny. Out of all this like really nice and quite complicated syntactic sugar and stuff that's making everything really complicated things in a really difficult way make it simple, is it true that the most recent and futuristic thing that it was on everything you explained was the print statement in 23?
Yeah.
That's the last thing they made?
Everything builds together. So in what I kind of hinted at here, where was it? Yeah, here. The fact that we can pass values in template arguments. Over time, it started off with just integers and other things which were very simple. And now we've got to an idea that anything that's a structural type, that, bitwise, that is fine. Knocking my mic. And that's what's needed in order to make that work. So that it actually translates this value known at compile time into something that can be templated. Because what's actually happening is translating that into some other magic types. Yeah. But yeah, that's what it's doing.
Yeah, makes sense.
Cool. Right, I'll just quickly show you those couple of C++ demos, just in case they spark your interest. So this is using a different feature of C++, known as a fold. So I can actually go, again, template thing, these are all different numbers. I can go from 1 multiplied by 2, 3, 4, 5, 6 to I. And so this is a fold expression happening at compile time. So I can actually do the Fibonacci, the factorial function at compile time in this way instead. It's not the nicest syntax, but it's a way of doing it. And then other libraries that come quite nice. So there's a ranges library where I can actually zip 2 bits of data together, and then I can sort over the zipped thing. And so I can do a projection just over the first bit of the key, and that's going to sort both this collection and this collection. And so by the time I look at the data later on, it is expected and it becomes sorted. So I end up sorting both of these, but by a key. And I know there's libraries out there that do this, but I think the way that the C++ libraries are being built up make this nice going forward. All right. Thank you very much.